Hello and welcome to Oplattery Videos, here to help you study, learn and succeed. Today's video is about electroplating. It's part of electrolysis, so there are some things that are going to require you to know about electrolysis as well, but I'll kind of put the basics in as we go through. So electroplating, how do we start? Well, simple start is our circuit that we're going to need for that. So we've got a low voltage DC supply. DC, remember, is direct current. It will only go in one direction, so that's why we want that. We don't want AC, alternating current. That, remember, changes direction 50 times a second. So one way that I always remember these two, less ink to write a minus, therefore that's my negative side. More to write a plus, therefore this is my plus side. So I'm going to draw my simple circuit. So obviously if you were doing this for an exam situation, you would be using a pencil and a ruler. I'm not, but obviously not in an exam. So two things in my circuit. I've got the plating metal on one side and I've got the item to be plated on the other. It's obviously going to be in a beaker if I'm doing it in a lab, and that beaker needs to be full of whatever the liquid is containing the ions I am plating with. So I then put my liquid on. So my two electrodes, well, first electrode, as I said, on this side I've got the object I am plating, so for example a copper ring. This is attached to the negative side, therefore it is negative. On the other side, I've got the metal I am plating with, so this side is made of, this time, my silver. And it's my metal. Again, if I trace my circuit round, this is the positive side. I said earlier I have to have a liquid. My liquid is an electrolyte. So if you go back to electrolysis, remember an electrolyte is an ionic liquid. It's dissolved in water. It therefore contains the ion that you are going to be plating with. So this time my electrolyte contains, it's a solution containing the ions I'm plating with. So it's a solution and it contains the ions I'm plating with. Okay, at this point I'm going to introduce three phrases. Those three phrases are going to help us with the rest of this. So, first of all, don't panic about this stuff. P-A-N-I-C. First phrase. Second phrase is, sounds strange but relates directly to this. I want us to think about an oil rig. Third one, well, personally I'm positively crazy about cats. So how are these three phrases going to help me with what I need to know? Well, panic, positive, anode, negative is cathode. That will allow me to identify now my anode and cathode. So positive anode, that means this side, my silver metal that I'm plating with is positive. This must be my anode. I've got negative is cathode. So again, if I follow the negative supply round, I said my copper ring was negative. Therefore, this side must be my cathode. Okay, oil rig and positively crazy about cats. Well, two more statements, as I said, two more kind of phrases, if you want to think of them like that, that are going to come in when we look at the equations that are involved, or the half equations involved in electroplating. So first of all, if I look at my anode is made of silver. Silver's shown as a symbol Ag. It's solid. What's going to happen? Well, my silver is going to go into the liquid. It's going to donate electrons at that point in time. If it's donating electrons, it itself is going to become positive. So I have silver ions, Ag+, aqueous, showing it's in water, and electrons. So these ions that I'm plating with are going to be, in this case, silver, and a good example we could use here if we wanted to would be silver nitrate. Okay, so I've got one half equation. I want to know what's going on at the other side. So my positive silver ions are going to be attracted to my negative cathode. So on the other side I've got my silver ions, at which point they're attracted to my negative cathode, they gain electrons and then become silver atoms again and are deposited on the copper ring. Okay, so now I need to use these two. So oil rig, I want to know about oxidation and reduction. So oxidation is loss, reduction is gain, and both of those are of electrons. We have both occurring simultaneously with any situation. So the easiest one to look at here, I'm gaining an electron, so this one must be reduction. Both happening simultaneously. If one is reduction, the other must be oxidation. So I can now add these onto what's going on. So my anode is where my silver solid is becoming silver ions. So this side is my oxidation. On this side, my copper ring is getting plated with the silver, so the silver ions are becoming solid silver atoms again. So this side is my reduction. Last one, if I need to say if they're cations or anions moving around inside my solution. With electroplating, we're only going to talk about one of the ions, however. So I've said I'm positively crazy about cats. Cations are positive. So we can say that the ion that we're talking about in this instance is a positive cation. Okay, so electroplating in a nutshell. We need to have a simple low voltage DC supply into a circuit. That circuit must contain one electrode, the anode of the metal that we're plating with. The second electrode must be what we want to plate. In this instance, I've suggested a copper ring. That's my negative electrode. So when I know those two things, I know what my metal ion is. That must be in my electrolyte. So my metal ion in this case is going to be silver. I've chosen silver nitrate as the electrolyte. Remember, the electrolyte must be a solution. Much lower temperature. If I can dissolve it in water, it will work that way. Remember, an ionic solution will dissolve in water. It's ionics that will become electrolytes and undergo electrolysis. If I look at my anode, my silver solid is then being taken into silver ions and an electron is being released. That's my oxidation side. Oxidation is loss of electrons. The silver has lost an electron to form a silver ion. At my cathode then, My silver ion is picking up an electron and making silver solid, so reduction is gain of electrons. Therefore I can identify oxidation or reduction. I can then put those on my diagram as well. If I want to know which my anode and which my cathode are, remember the phrase, don't panic about this. You've got a positive anode, follow it round, there's my positive side, and a negative cathode. Follow it round, there's my negative side. And if you want to know whether it's a cation or an anion, well, I am personally positively crazy about cats, therefore I've got cations involved. The opposite is going to be true. If I don't have a cation, a positive ion, my negative ion is then going to be an anion. So we can also see that anions, negative ions, are attracted to positive electrode. Remember, opposites attract. Your cation, your positive electrode ion, is going to be attracted to your negative electrode, your cathode. So, electroplating in a very simple, straightforward nutshell. Thank you for watching Oplattery videos, and I'll see you again soon.